A new way volcanoes form from Earth's deep mantle. This is what scientists have found. A new article from Cornell University on phys.org by Blaine Friedlander. From Earth's deep mantle, scientists find a new way volcanoes form. We have here the diagram. They're taking the example of Bermuda, that has a unique volcanic past. About 30 million years ago, they show us the cross-section between the transition zone between the lower mantle and the upper mantle. There's a transition zone about 250 miles deep. It's under the upper mantle, between the upper and the lower mantle. And of course, underneath the lower mantle, we have the inner core. The upper mantle, transition zone, and there's an upwelling from the transition zone through the upper mantle towards the crust. Far below Bermuda's pink sand beaches and turquoise tides, geoscientists have discovered the first direct evidence that material from deep within Earth's mantle transition zone, that's a layer rich in water, by the way, rich in water, crystals and melted rock can percolate to the surface to form volcanoes. That's why sometimes, for example, when we saw the Kilauea eruption, when we saw that lava flows going at 18 miles an hour, it looked like a river. It was fascinating to watch. It was so fast flowing. It looked like a river. And it's a river of melted rock, because the rock has so much water in it, obviously, because it's coming from this water-rich transition zone. Scientists have long known that volcanoes form when tectonic plates traveling on top of the Earth's mantle converge, or as a result of mantle plumes that rise from the core mantle boundary to make hotspots at Earth's crust. But obtaining evidence that material emanating from the Earth's mantle's transition zone between 250 to 400 miles beneath our planet's crust can cause volcanoes to form is new to geologists. They say we found a new way to make volcanoes. This is the first time we found a clear indication from the transition zone deep in the Earth's mantle that volcanoes can form this way. This is what senior author Esteban Gazal, Associate Professor of the Department of Earth and Atmospheric Sciences at Cornell University. The research published in Nature magazine states. Cornell University, Ithaca, New York. I used to live there, by the way, beautiful little town. I think that's where John Philip Sousa used to have, did you ever hear the marches of John Philip Sousa? I'm going to make another video with links to that. Oh, fantastic marches. They're marches for, they're marching band songs. Now, they used to have a lot of marching bands about 100, 200 years ago in the States, celebrating various things. Not anymore. Now, that's in Ithaca. Now, they say we were expecting our data to show the volcano was a mantle plume formation, an upwelling from deeper mantle, just like it is in Hawaii. Gazelle said, about 30 million years ago, a disturbance in the transition zone, we're talking about Bermuda, caused an upwelling of magma material to rise to the surface, forming a now dormant volcano under the Atlantic Ocean and then forming Bermuda. Using a 2,600-foot core sample drilled in 1972, housed at Dalhousie University, Nova Scotia, co-author Sarah Maza of the University of Münster in Germany amassed the cross-section for isotopes, trace metals, trace elements, evidence of water content, and other volatile material. The assessment provided a geologic volcanic history of Bermuda. She said, I first expected that Bermuda's volcanic past was special, as I sampled the core and noticed the diverse textures and mineralogy preserved in the different lava flows, Maza said, and continued to say, we quickly confirmed extreme enrichments in trace element compositions. It was exciting going over our first results. The mysteries of Bermuda started to unfold. From the core samples, the group detected geochemical signatures from the transition zone, which included larger amounts of water encased in the crystals that were found in subduction zones. Water in subduction zones recycles back to the Earth's surface. There is enough water in the transition zone to form at least 3 oceans, according to Gazelle, but it is the water that helps the rock to melt in the transition zone. So I wonder if a lot of this water also comes out as geysers in Yellowstone, for example, that has 60% of the world's geysers. It could be that it's not related to rain or groundwater. It could be that it's coming out from the volcano itself. So there you go. You find things out, there's new things coming out all the time. The geoscientists developed numerical models with Robert Mucha, Associate Professor of Earth Sciences at Syracuse University. Syracuse is very close to Ithaca, by the way. Syracuse University to discover a disturbance in the transition zone that likely forced material from this deep mantle layer to melt and percolate to the surface, Gazelle said. Despite more than 50 years of isotopic measurements in oceanic lavas, the peculiar and extreme isotopes measured in the Bermuda lava core have not been observed before. Yet these extreme isotopic compositions allow the scientists to identify the unique source of the lava. Quote, if we start to look more carefully, I believe we're going to find these geochemical signatures in more places, said co-author Michael Bizimis, Associate Professor of the University of South Carolina. Gazelle explained that this research provides a new connection between the transition zone layer and volcanoes on the surface of the Earth. With this work, we can demonstrate that the Earth's transition zone is an extreme chemical reservoir, Gazelle said. We're now beginning to recognize its importance in terms of global geodynamics and even volcanism. Gazelle said, our next step is to examine more locations to determine the difference between geological processes that can result in intraplate volcanoes, and determine the role of the mantle's transition zone in the evolution of our planet. And something else having to do with water at the boundary between the upper and lower mantle. Diamonds are found there. Diamond inclusions suggest free-flowing water at boundary between upper and lower mantle. That's another thing that they found. This again on phys.org by Bob Eureka. The team of researchers from the US, China, and Canada has found evidence in diamonds of free-flowing water in the boundary between Earth's upper and lower mantle. In their paper published in journal Science, the group described the analyzing inclusions in diamonds spewed from volcanoes and what they found. The researchers were looking for molecular forms of carbon dioxide as part of carbon cycling in the Earth's mantle when they came across evidence of something else. Well, we know that, with every volcanic eruption, we have a lot of carbon dioxide coming out. I mean, there's a lot more carbon dioxide from the volcanic eruptions that we have all year with, or I don't know how many years, I forget how many, quite a lot more than we have from the pollution of man-made pollutants in the atmosphere. It's basically, most of it's coming from volcanic carbon dioxide. But anyway, they were looking for the carbon dioxide in the in these samples, and they came across evidence of something else. They had collected diamonds spewed from volcanoes or pushed to the surface by other geologic activity in Zaire, China, Sierra Leone, and other locations in southern Africa, and were studying them by bouncing X-rays off the diamonds inclusions when they came across samples of ice-7, a form of ice that does not occur naturally at the surface. The find was significant because ice-7, or VII, ice-7, forms a very high pressure, approximately the amount of pressure found at depths of 610 to 800 kilometers beneath the Earth's surface. This, the team note, suggests that water must have been freely flowing at such depths to form the inclusions they observed. Free flowing water, can you imagine? Oceans of water between the upper and lower crust. Such depths, they further note, fall into the transition zone in the mantle, a part of the Earth's interior that is still a source of mystery. Prior research has shown that the mantle is made up mostly of hot rock under a lot of pressure. It has a lower layer, closest to the core, a transition layer, and an upper layer that eventually meets the crust. Well, we're talking about the transition layer being full of water. Prior research also shows that the upper mantle has some water, which hints that there may also be water in the transition layer. The diamonds the researchers were studying would have been encased in liquid somewhere in the transitional zone. The high temperatures there would not have allowed them to crystallize. However, it was only as they moved to the surface that crystallization would have occurred. The high pressure would have been maintained inside the diamond, but the temperature would have dropped dramatically. The idea of water moving around in the transition layer is intriguing, the team reports, because it has implications for tectonic plate shifting. This reminds us of what is written in the Old Testament of the Bible, that the earth is floating on the water. I'm sitting here rolling my eyes. I have to find that passage, but the earth is floating on the water. It's written in the Bible. So I'll leave links below for you for these two articles on phys.org. Very interesting. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.